Hello, my name is Wes Morgan, and I'm a data development specialist here at IMPLAN. In light of our most recent release of occupation and core competencies data for the 2020 data year, we as a data team wanted to reach out to give some insight into what we do. Today, I'm going to be talking to you about the production cycle from our data team's perspective on occupational and core competencies data. For more information on where this data can be accessed and how it can be used, please visit support.implan.com. Onto the agenda, I'm going to give an overview of what the data looks like and some key assumptions that go into producing it for both the occupational and core competencies data. Then I'll go over the sources that we use and include a special acknowledgement about a source that has some specific 2020 considerations and conclude. All right, so occupational data. To give an idea of what this data looks like just from the start, I have included a excerpt from our 2019 IMPLAN application. This data gives us a breakdown of what jobs exist in each industry, what the pay split looks like between all of those jobs, and what hours worked for those jobs looks like. We'll see a display for the occupation code, its name, wage and salary employment count, and wages, supplements to wages. And those two together make our employee compensation, wages plus supplements to wages, and then the hours worked for that job. I'll go into more detail about how we move from what our data team produces until how it gets to this final stage now. So all occupation data that the data team produces is produced in the form of ratios. All the ratios that we create represent percentages of a whole, and in this case, that whole adds to 1. Each whole corresponds to an industry and IMPLAN at the national level. That is, ratios describe the percentage for allocation of occupations or wages within each industry. To give an example, let's take a look at a row of data from the data team's 2020 database. Here, we can see an IMPLAN code, which just corresponds to an industry, an occupation code, group, year, sector scheme, and then most importantly, 2 shares. The employment share corresponds to wage and salaries employees, and the wage share corresponds to a percent of wages. So this particular row, this example, would be telling me that in industry 1, which is oilseed farming in IMPLAN, about 5.7% of employees, and that is only employees, not proprietors, have the occupation 11-90-10 farmers, ranchers, and other agricultural managers. This is all produced at the national level. In a very similar vein, the wage share column in this example tells me that about 10.1% of wage and salary income, not including proprietor income, goes to that same occupation 11-90-10. Each year, we produce something like 200,000 rows of data that look just like that. And they cover every industry for the data year at the national level at 5 different group levels of occupations. Groups, circled here in red at the very bottom, represent a hierarchy of occupational codes. This can be thought of similarly to an aggregation scheme. So we have 5 levels of groups, which contain all of our total occupations. First, we have the total, which has only 1 code in it, and that's 00-0000. That is a group that is a sum of every occupation added together. Then we have major, minor, broad, and detail level codes. I put some examples out to the side of this hierarchy just to illustrate that as we go to more detailed codes, occupations become more and more specific. So for instance, while the major level code of 270000 contains art, design, and media occupations, as you add more numbers to that code, you kind of whittle down to something really more specific, something like actors, which is code 272011. All of these groups roll up together. So if I were to add all the major codes together, they would add up to the total. And if I were to add all the minor codes up, they would also equal the total. But if I were to add all the minor codes that begin with 27 hyphen, then they would add up to the major code of 270000. I've also included a code count just for anyone who is curious. These codes are applicable for the 2019 and 2018 and 2020 data in IMPLAN currently. So around some assumptions, as I mentioned a couple of times, these data are produced at the national level, but we're still able to produce regionally specific data. So how do we do that? Well, we multiply the ratios that we produce by the study area data that's already found in the IMPLAN application. For instance, if we were to look at a 2020 geography where Industry 1 had 100 employees, we would take our employment share of 0.057 from earlier, and multiplying that out by 100, we'd end up with 5.7 employees that have the occupation of 11, 90, 10 in that fictional region. So it's really the study area combined with the occupation data that gives us the detail that we're looking for. On its own, the occupational data doesn't tell us quite as much. Another assumption about the occupation data, I've stressed this one already, the data is at the national level only. So there is just one set of ratios for each industry. This is also only wage and salary employment, meaning that there is no data for proprietors included, and that includes a proprietorship count as well as proprietor income. And that's really a good thing because the source data that we use from OES is really only meant to be estimates for employees. So we're kind of just staying consistent with our sources here. There are also some non-disclosed values within the data set, meaning that there are intentional holes poked in the data. So IMPLAN does have a disclosure process in place for those. Basically, we typically tend to use data from other sources or from larger categories to kind of help fill things in. Occupation hours data is also used to adjust wages. So for instance, we want to make sure that someone who's only working part-time is only going to get the pay for part-time work. Source data for occupation data does typically tend to include an assumption that people work 40 hours a week, 52 weeks a year. So we kind of want to correct for that. And then we also diverge from the SOC coding scheme at times. This is particularly prevalent when it comes to military, because we do use our own SOC codes that basically allow us to incorporate additional data, which gives us some better detail. So that covers a quick look at the structure of occupation data. Now I'm going to go ahead and move on to the core competencies data. So looking at these core competencies, I did break this section into two parts, dividing the knowledge, skills, and abilities, or what we refer to as the KSAs, from education and then the work experience and on-the-job training categories. This was done because there are some different assumptions and levels of effort that go into producing each of these kinds of data that really keeps them distinct. So the KSA work is going to be first. So really similar to the occupation data, KSA basically behaves the exact same in terms of structure, though they don't have a hierarchy with multiple groups. We once again produce ratios for this data, but when they're displayed in IMPLAN, we use a scale of 100 for each KSA instead of a scale of 1. They come in a scale of 1 in our database, but we convert them to a 100 scale system later. And I'll touch on the reasons why we do that in just a bit. So KSAs are bridged to our occupational codes. So off of an industry, we take an industry employment count and split that out into occupations. And then we take the the occupation codes and split that out into the different KSAs. In order to do this, there are some pretty important assumptions that we make. So to address this, I first want to talk about scales. We do not have a bridge anywhere that says a certain occupation requires certain knowledge or skills. Rather, the raw data that the data team at IMPLAN receives has a scale for level and importance. These basically can be interpreted as the degree to which you have said KSA and the importance of having that KSA for the associated occupation. The level scale goes from 0 to 7 and the importance scale goes from 0 to 5. So a 5 importance and 7 level scaling for a piece of knowledge, for example, would mean that for a specific occupation, you would really have to know something and know it to a really in-depth degree for that occupation. In order to convert this to something useful, we use our very first assumption, which is the multiplicative interactions of scales assumption. This was developed by Philip Watson, PhD. To do this, we follow a procedure like so. So let's say that in order to be an IMPLAN economist, the knowledge importance required for economics is 5, and the level for economics is 7. We would convert that to an initial system of points by taking 5 multiplied by 7 to get 35 points for economics. Then we would bridge that 35 points to that occupation. Now, that only represents one of our knowledge components, and there are quite a few. So if we go through that same process for all the others, just multiplying level by importance, we'll get an initial estimate of those points for every KSA. So if we were to stick with an example and pretend that the only 2 pieces of knowledge needed to be an IMPLAN economist were math and economics, and they both had 5-7 ratings, we would produce an initial estimate of 35 points for both of those pieces of knowledge. Then we can sum each of those up to split out and produce a 100-point scale with. And essentially with a 35-35 split, we would just get a 50-50 split for our 2 knowledge items. Thus, we have a ratio. Basically, this is the process that's repeated for each piece of knowledge, skills, and abilities. As you might have guessed, this leads into that second assumption that I mentioned earlier, that each job uses 100 units of KSAs. That really means that there is no difference between total KSAs for distinct jobs, only a difference in the distribution. So for example, if someone were to switch jobs in your regional geography, they don't get to bring their 100 points of knowledge, skills, and abilities from job A and add them to a 100-point job B and have 200 points. They now simply have a different set of KSAs. This ties directly into our third assumption, which is that KSAs are associated with employment in the region, not the employees. Basically, we're estimating KSAs in the region based on what employment looks like, not the other way around. So plenty of people probably do have KSAs that they don't use for their job, but those are just not going to be represented in this data set. All right, so as I mentioned, I wanted to split out those KSAs from the other core competencies, and that's because education and work experience and on-the-job training do not use that multiplicative scaling assumption. Instead, we actually do have some data on how educated people are in your geography and how much training jobs require, so we can just create those ratios a lot more easily. In terms of core competencies data counts, I did also include charts. Feel free to pause this video to take a look at the counts for each of these pieces of information. Regarding data sources, so the very first and probably the largest, most used piece of data that IMPLAN utilizes is the Occupational Employment Survey, or the OES. This comes from the Bureau of Labor Statistics and covers almost all the occupations that we use, save for things like military and agriculture. This is also released annually. Next, we do also use the Employment Projections National Industry by Occupation Matrix, which covers some of the occupations that the OES data don't have and helps us to fill in some gaps, and that releases every other year. On the core competency side, we have ONET data, which is produced by the Department of Labor. And the most recent data set that we have obtained and incorporated, and this would be for the 2020 data, is the 26.1 set. Lastly, we have the American Community Survey, or ACS Public Use Microdata Sample. There is a specific caveat regarding this for 2020, but basically this data is used just to cover the hours portion of occupation data. So with this data in 2020, data quality suffered greatly because of response rates. And this is largely due to the effect of the COVID-19 pandemic. Typically, the Bureau tries to aim for a 1% representational sample of the geographies that they cover, but this was not achieved during the height of the pandemic. And a study ran kind of indicated that there were some pretty significant economic disparities between respondents, in that more higher income households responded and less lower income households responded. So this introduced a source of bias, which in order to combat, they used a new methodology for weighting their data, and it was released only as an experimental set. But IMPLAN decided to go ahead and use this data regardless. The reasons for that are that, one, there was just not really a suitable set of replacement data. And then two, the experimental weights were developed and targeted mostly at producing state level and lower estimates. But as I mentioned at that first assumption, IMPLAN uses national data, so we're a lot less affected. That concludes our brief look into how the data team here at IMPLAN produces occupation and core competencies data. Once again, if you do find yourself with questions or are just interested in using this data in a study, please don't hesitate to reach out to us at support.implan.com. IMPLAN employs a full suite of economists that are eager to assist our customers and help produce the best studies possible. So strongly encourage that you make use of those resources. Thank you for watching.